Good morning, dear children. Now, today we'll discuss with a new chapter. We'll start a new chapter today, chapter 5, energy. Now, before we come to this topic, the term energy, let us first discuss about the work. Okay, first we'll discuss about the term work done. Now, as we all know that we perform various type of work. We do work at home. People they work in factories. Okay, they work in office. They work in school. So that means in the various field, the people they do work. So we do work. Various type of work we do every day. And when we perform a work, some force is applied there. And when the force is applied to perform a work, when force is applied, that force will have to produce some displacement or the distance. When the force is applied on an object and when that object moves in the direction of the force, then we say the work is done. Suppose in a school, suppose you are sitting at one place and you are writing. You are sitting at one place, you are writing, you are talking, you are eating. So that is also the work. But in terms of physics, we cannot say that remaining at one place and moving your hands, eating, writing, okay, talking, all these things we do remaining at one place, we cannot say that the work is done. That means the physics doesn't say, the science does not say that the work is done by a person, because that person, whoever is doing a work, is remaining at one place. He or she does not produce any displacement or does not move from one place to another. Okay, but in common way we think that we are doing some work. Okay, when we are lifting a load, okay, suppose I told you, suppose if I tell you to carry a stone, you just carry a stone and stand in one place. Okay, you don't move, remain at one place, and after some time you get tired because of carrying a stone. Okay, for a long time you get tired, you start perspiring, and you think yourself that you have done some work. But in terms of physics, no work is done. Though you are lifting a stone, you are applying a force on the stone, but you are not moving. That means the stone is not producing a displacement, or you are not making any distance, or you are not producing any displacement. So in that case, no work is done. So the work has to be done when the force applied on a body, that body has to move. Example, kicking a ball. Just ball is an object. Okay, when you hold a ball in your hand, okay, no work is done. But when you throw the ball from your hand, when you throw the ball covers some displacement and the work is done. Okay. Similarly, when you carry a stone and you move, okay, when you move from a point from one place to another, so in that case work is done. Because when we apply the force, it has to produce displacement. When you only apply the force and there is no displacement, no work is done. Again, another example. If you push a wall, a rigid wall is there. If you try to push the wall does not move. You apply enormous energy, the enormous force you apply, but the wall will remain at the same place. It remains as it is, though you apply number of forces there. Okay, you will get tired after pushing a wall. You will get tired, but the wall does not move. So what happens there? Though the force is applied there, but the wall does not produce any displacement. In that case, no work is done. So therefore, we can say that work is done only when a force applied on a body makes a body to move, or the body produce displacement. So when we come to the definition of work done. So how you define work done? Means work is said to be done when the force applied on a body produces the displacement in the direction of the force. Whichever direction you apply the force, in the same direction, the body has to produce the displacement. Only in that case the work is done. Okay, so therefore the work done can be given as W equals to F into S. From the definition of work done, it can be written as W equals to F into S. That means F means the force, S means the displacement. So from the definition of work done, work is said to be done when the force applied on a body produces a displacement. So S is the displacement. So therefore this is the relation to find the work done. W equals to F into S. Then again the unit of work. Let us consider the unit of work. There are two units, CGS unit and the SI unit. So first of all, let us find the SI unit of work done. So SI unit means System International Unit. So SI unit means, what is the SI unit of force? The SI unit of force is Newton. Okay, N-E-W-T-O-N, Newton, and the SI unit of displacement is meter. So the SI unit of work done is Newton meter, or it can be written as Joule. Okay, it can be written as Joule. Okay, and this the SI unit of work done, or SI unit of work is Newton meter, or can be written as Joule. So similarly, the CGS unit of work is, the CGS unit of force is dyne. Then the CGS unit of displacement is centimeter. Okay, CGS unit is centimeter. So the CGS unit of work done is dyne centimeter. So CGS unit of work done is dyne centimeter, and the SI unit of work done is Newton meter, and it is also known as Joule. Okay, now what is Joule? Now let us come to the definition of a Joule. 1 Joule is the work done. That means the SI unit of work done is Joule. So I can write it here Joule. So instead of the work done, I will write it here 1 Joule equals to 1 Newton into, I can write 1 meter. So what is Joule? So instead of W, I have written here Joule because the SI unit of work is Joule. And the SI unit of force is Newton. I have written here Newton. SI unit of displacement is meter. So I have written here 1 Joule, 1 Newton and 1 meter. It's just multiplied by 1 time here. So how do you define Joule? Oh, 1 Joule, we can define as Joule. 1 Joule is the work done when a force of 1 Newton acts on a body and produces a displacement of 1 meter in the direction of the force. So Joule means, so 1 Joule is the work done when a force of 1 Newton acts on a body and that body produces a displacement of 1 meter in the direction of the force, then it is said to be as 1 Joule. So this is the definition of Joule. And next one is here, the work done can be negative and 0. Okay, the two conditions are the work done can be negative and 0. So when the work done is negative, is 0, the work done is 0 when the body does not produce displacement. Okay, now I give you the example that the first example is there. When you push a wall, okay, you apply the force on the wall, but the wall does not move. So that means on any object, when you apply the force and that object does not move, then we say that no work is done. So the work done will become 0. Again, another one. Suppose if a body moves in a circular path. Suppose a body moves from this point. And the point where a body starts moving, that point is known as the initial point. I-N-I-T-I-A-L. Initial point. Initial means the starting point. Suppose a man starts from this point. That is, this is the initial point. Then he moves around and come back to the same place. So what happens here is that the initial position and the final position of the body will coincide. That means they come back to the same point, and therefore in that case also no work is done, because whatever displacement covered by the body will become 0. Okay, because since the body is starting from the initial position, and after making a round he will come back to the same position. So therefore the initial position, the starting point, and the final position of the body will come at the same point. So therefore there will be no displacement. So the displacement will become 0. So when the displacement will become 0, therefore no work is done. Okay, then also the work done can be zero in the two cases here. Okay, number one is if there is no displacement, the work done can be zero, and if the displacement will become zero, again the work is not done. Okay, it becomes zero. Now the work done will become negative. Now when the work done will become negative is that when you apply the force, okay, and the body moves in the opposite direction to the applied force here. Suppose you push a wall, you push an object towards left side, this side, and the body moves towards the opposite side. Okay, so in that case, the work done will become negative. So therefore, the work done will become negative when the force applied on a body will move in the opposite direction. Then the work done will become negative. Example is the force of friction. Okay, the force of friction. When a force is applied on the body and the friction is produced on the body, in that case the work done will become negative. So this is about the work done, okay, and also the CGS and SI unit of work and the factors on which the work done affects. What are the two factors on which the work done affects are? Number one factor is the force applied on the body, and other one is the displacement produced on the body. So the work done depends upon the two factors. One is the force which acts in the body, and other one is the displacement which produces the body to move. So these are two factors on which the work done depends. Thank you.